energetics. Do you have your water bottle with you? Here, wait. For the energetics lesson, this is your tune. And we have to do a lot of questions under energetics lesson. Delta H questions, delta S questions you may, while you will learn, you can understand what is the delta H, what is the delta S and what is delta G. But only doing more and more calculations, right? So you need this tune with you. I think if you make your payment, this is the last week for the free session. From next week onwards, you need to pay and join with the class. Okay, you can take this tune once your payment is done, right? Okay. The lesson I can categorize into 4 major parts. Basic concepts, basic terms, enthalpy, entropy, enthalpy change, entropy change, and Gibbs energy. Under the enthalpy change, we need to calculate enthalpy. We need to quantify the value for the enthalpy change. So, delta H calculation. So that we need direct method to calculate. I think you don't know what is direct method and indirect method. So it's okay. Just write down what are the things we are going to learn. Then gradually you will understand the pattern of my teaching. And first day I am doing basic terms, and the second terms enthalpy calculations, third term entropy changes, and last session in Gibbs energy. During these sessions I will do some calculations with you. I will do some questions to do homework. So I can discuss more questions with you. Likewise, I think it's better to interact. If you interact with me, it's better to go through these lessons very quickly, right? Rebecca and Deborah, they are okay. Direct method and the indirect method. In the direct method calculations, I think, okay, there is one equation. In indirect methods, you will have 2 methods to do the calculations for the delta H. For today's basic term. Today, you will go through the basic terms of enthalpy lesson, energetics lesson. Can you note down in your book? Once you complete, please raise your hand or give me some hint that you are complete. Then I can go to the lesson. Then, first term, energetics. Write down the first term, energetics. The basic terms, under basic terms, you will learn basic terms of energetics. Okay, before that, if anyone needs explanation in Sinhala medium, if anyone needs explanation in Sinhala, can you raise your hand and say, Miss, I need some Sinhala explanation too. Anyone like that? Or else I will explain fully in English, or some after the full in English explanation, I can explain in Sinhala if you want. That's why I ask if anyone needs Sinhala explanation along with English explanation. Okay, you all are familiar with English then. Is it okay? Induvarni, is it okay to explain everything in English? Or you need some single explanation too? After the, but it's only after the full English explanation. Okay, let's see. In basic terms, you need to know what is thermal energy. What is thermal energy? And what is heat? What is system? What is boundary? And what is surrounding? And what is enthalpy? What is state of a system? And what is state variables? Those are the basic terms under the energetics lesson. So, what is thermal energy? Thermal energy is something which arises due to heat, due to temperature. Let's see, if you have a hot tea with you, that hot tea contains high thermal energy than normal water. Which means, in hot tea, you have some energy is because of heat or is because of temperature. If particular system contains the energy due to the heat, those are called thermal energy. Any doubts? Okay, write down under thermal energy. The energy content, write down under thermal energy. The energy content within the system, the energy content within the system that is responsible for its temperature. That is for its temperature. Again, the energy within the system that is responsible for its temperature. Here I am also one type of system. Can you feel, you can't feel your heat. Okay, yeah, yeah, we can feel our heat. Okay, once your hands and take like this, then you can feel your heat. Right? You can feel some temperature. Okay, is because the thermal energy in your body. right? If you have your sibling with you, if you have a brother with you or sister with you, just tap කරන්න පොඩ්ඩක්, just tap or just touch him or her, and yeah, you can feel some heat, right? It's because of the thermal energy of that particular person, right? Likewise, if you have a cup of tea with you, hot cup of tea with you, once you touch that mug, you can feel some heat, right? So that particular mug contains thermal energy than your body. That's why you feel that thermal energy. Can you? Are you clear with now what is the thermal energy? Are you clear with the thermal energy? I need some response, at least you either thumb up or anything. I need your response. Okay. Then what is heat? Heat is transfer of thermal energy from high thermal energy system to low thermal energy system is heat. The transfer mode of energy transfer mode of is called heat. Okay, write down under heat. It's transfer of thermal energy. It's transfer of thermal energy between two bodies. Transfer of thermal energy between two bodies that are at different temperature. That are at different temperature. Transfer of thermal energy between two bodies that are at different temperature. If the systems are in two different thermal energies, so the system with high thermal energy can transfer energy into system with low thermal energy in the mode of heat. Clear? Clear? If there is one particular system with high thermal energy, just like 100 Celsius, water, then it can transfer the thermal energy into surrounding in the form of heat. Heat is the form which transfer energy from high thermal energy bodies to low thermal energy bodies. Then the third one. Okay, now we are moving into very basic terms. What is system? What is boundary and what is surrounding? Do you have your water bottle with? Can you take your water bottle with you, like me, or your mug or something? This is a system. This is my system, right? It's a thing. It's any portion of matter which separates surrounding. This one around the system, I can feel, I can touch. Everything is surrounding. May take a surrounding. This one surrounding. Right? This is system. Right? Okay. Then this wall of the system, sometimes you will have metal water bottle, a glass water bottle or plastic water bottle. The wall of the system is called boundary. Right? So this is one type of particular system. Right? Are you clear? Clear? Are you clear? It's a one type of system. It's a portion of universe, and the wall of the system is called boundary. And if I open the lid, this system is called open system. If I close the lid, this system is called the closed system. Right? Okay. Then write down. Then first we'll draw some system. You can draw it like a bottle or mug or something. I just draw as a square. And I consider inside this crisis system, the lines boundary and this one surrounding. Right? Then first find what is bound. What is bound? It is anything. It is anything. Anything which separate the system. It is anything which separate the system from its surrounding. From its surrounding. Write down again under boundary. It is anything which separate the system from its surrounding. Then write down under surrounding. Surrounding. The surroundings are sorry, surroundings are considered to be all other portion of universe, the surroundings are considered to be all other portion of universe which can be interact with the system, which can be interact with the system, which can be interact with the system. If your mud is a system, it can interact with the surrounding through exchange in the heat. So it can exchange with the surrounding. The surroundings are considered to be all other portions of universe which can be interact with the system. Okay, then system, write down under system. Some arrow here. The definition of the system. Write down the definition of the system. Any portion of matter or universe, any portion of matter or universe under consideration, which is separated from the rest of the universe. Which is separated from the rest of the universe. Okay. If I consider this bottle is any portion of the universe which is separate from the rest of the universe. Right? You can have your bottle with you and you can look at that system. A beaker is a particular system in lab. In your house, rice cooker with rice is particular system. As everywhere we can find systems. Right? Any portion of universe which interact with the surrounding or separate from the rest of the universe. Okay. Then I can categorize these systems into 5 major parts. Right? I can categorize this system into 5 major parts. Okay. Then I can categorize the system open system, closed system. Write down with me. Isolate system, homogeneous system, and last, heterogeneous system. open system, closed system, isolate system, homogeneous system, heterogeneous system. Right? Okay. In the open system, take your water bottle again. If you open this lid, then if I put some hot water inside to this bottle, water vapor will evaporate from the mouth, from here. Then water vapor evaporize means it can exchange the matter between the surrounding. Right? And the same time, I can feel the warmth of the body boundary, which means it's exchange the energy with the surrounding. If the system can exchange both matter and the energy with the surrounding, those systems are called open systems. If the system can exchange both matter and the energy with the surrounding, that system is called open system. The tea with you without any lid. If you have a tea with you without any lid, top of the mug, right? So that is an open system. So it can exchange water vapor with surrounding and the same time energy with the surrounding. So open systems can exchange both energy and matter. Open system can exchange, go this way, it can exchange matter and energy. Matter, it can exchange both matter and energy. Okay, if I come with the system, then I close this lid. If I close this lid, this one called a closed system, which means it can only exchange heat with surrounding, but not the matter, only the energy. If only exchange energy is here, the system only exchange energy, those systems are called closed systems. Closed system. No matter exchange. No matter exchange. Only energy exchange. Only energy can exchange. Right? Then what is isolate system? Isolate system just like the flask in your home, water flask. In particular time, for the small time period, it can retain the temperature constant. So that particular period, flask we can consider as a isolate system, which means it cannot exchange matter or the energy with the surrounding. No exchange of matter and the energy with the surrounding in isolate system. No energy or matter exchange. Matter no. Energy no. In chemistry, for the energetics lesson, we normally go with the closed system, right? Not the isolate system. Normally, we go with the closed system. Clear? Any doubts so far about these three systems and anything you need to know until so far? So, are you okay? Induvarni, are you okay? I need your engagement with me. Because I can't continue the class because I don't know whether you are learning or not. I need your collaboration with me. No problem. Understood. Okay. Rebecca and Deborah, I think you are my Rebecca. Are you there? Rebecca? Hello. Okay. Sorry to see you. Okay. Then homogeneous and heterogeneous systems. Homogeneous system. Homogeneous system means for that I will take some bottle this way. So this one my eau-de-cologne bottle. This is eau-de-cologne. And here I have two physical phases. Here I think you can see liquid phase and the vapor phase. There is only small portion of liquid here. So that system, this closed system, contain liquid phase and the gas phase. So that kind of systems are heterogeneous system, which means if the system contains more than one physical state, if the system contains more than one physical state, those systems are called heterogeneous systems. Then the opposite, if the system contains only one physical state, the things with one physical state or liquid phase or only gas phase or only solid phase. Likewise, there is only one physical state, those systems are called homogeneous system. Clear? Clear? Two types again, homogeneous system and heterogeneous system. If the system contains more than one physical state, those are heterogeneous system. If the system contains only one physical state, those are homogeneous system. Okay, then write down under the homogeneous system and heterogeneous system, write down first under homogeneous system. Physical state of all its matter. Physical state of all its matter. Physical state of all its matter are uniform. Physical state of all its matter are uniform. Physical state of all its matter are uniform. Then under heterogeneous, write down, if the system contains, do not possess the same physical phase. If the system contains, do not possess the same physical phase. Okay. That's all. I think if you like, you can draw the homogeneous system like this. It's similar, same types of dots. Then I can indicate whether it's gas phase or liquid phase. I think it's better with similar size. In heterogeneous systems, you can feel liquid phase and gas phase. There is only one gas phase. I think I will describe that way. So I think you can get an idea then by looking at the diagram. So what is homogeneous system? Oh, there is only one physical state inside the system. In heterogeneous system, there can be more or three or two or more physical state inside the system. Clear? Clear? Any doubts so far? Because we are moving into next part. If you have any question now, raise your hand or please drop your message, or you can ask directly from me. Any questions? If you don't have a question, it's also please mention that. Miss, shall we move into next session or anything? Clear. Okay, another way. Rebecca know how to response. Okay, clear. Okay, clear. Okay, thank you. Then next part, properties of a system. Okay. In next page, write down in the top of the page, properties of the system. This is for only today or afterwards. You can have this tube. You can have this tube. In the tube, you are given with that with here. Lights. You are the node. You need some space. You are given with some space, so you can fill that space. Only for theory. While doing theories, we are doing past paper questions. You need another book. It should be if it is okay, you can take a science book. It's more easy. I recommend science book, which means blank book, just blank pages. A blank book for the calculations or do some exercises in the chemistry, physical chemistry, right? Or else you can bind some half sheets with you. It's also okay, right? But anything, not the rule book. It's a blank. Better use blank book for the science subjects, not for the chemistry. Chemistry, physics, biology, same. Maths, same thing. Use as much as blank sheets to learn. Okay. Properties of the system. Properties, I can categorize into two major parts. What are the properties? Properties means something we can measure, we can tell about the system. Right? Okay. Properties of the system. I can write microscopic systems, microscopic properties. And the macroscopic properties. Macroscopic properties. Oh, it's easy. Microscopic properties and macroscopic properties. What is meant by microscopic properties? Microscopic properties mean the properties which are not visible. We can't measure, right? Like molecular kinetic speed, molecular kinetic energy or molecular speed, the things that we can't observe or things we can't measure directly. Those are called microscopic properties. Then what are the macroscopic properties of the system? Let's see this system. Inside this system, I can find some eau column. What are the macroscopic properties that system? I can measure the volume. The temperature, I can measure the temperature. Likewise, pressure, density, it's a refractive test. That the properties I can directly measure, those are called macroscopic properties. Okay? The properties which cannot measure, those are called microscopic properties. The properties, those are in the microscopic scale Those are called microscopic properties. The properties which can directly measure, like pressure, volume, temperature, those are called macroscopic properties of the system. Clear? Clear? Okay. No. Doubts there? Are there any doubts? Okay. Can you write down under microscopic system? Write down the properties in atomic or molecular scale. The properties, microscopic properties, right? The properties in atomic or molecular scale. The properties in atomic or molecular scale. A system is called a microscopic system. System is called a microscopic system if it is roughly of atomic dimension. If it is roughly of atomic dimension. Again, a system, the properties in atomic or molecular scale. A system is called a microscopic system if it is roughly of atomic dimension. Write down an example. Kinetic energy of molecules. Kinetic energy of molecules. And molecular speed. Molecular speed. Kinetic energy. Second one, molecular speed. Okay, then write down under macroscopic properties. I think you can have an idea. About macroscopic properties. Okay, write down the properties which are associated with bulk or macroscopic state of the system. The properties which are associated with bulk or macroscopic state of the system. Write down an examples. Pressure, volume, temperature, P, T, V, concentration, density, viscosity, surface tension, refractive index, and color. Okay. Again another thing to learn. Those macroscopic properties which are in the bulk, or normally we measure values. Okay, those macroscopic properties I can categorize into again two major parts: extensive properties Write down with me. Extensive properties and intensive properties. Extensive properties and intensive properties. Right? Okay. What is meant by extensive property? Okay. I will take that system, two systems. Correct. Here. This is one system and this is another system. Here. The physical parameters which depend on the size of the system. This is a small system compared to this system, right? This system is smaller than this one. So, is because the system is small, the volume of that system is less than this system. Clear? Clear? Then, volume is depend on the size of the system. Likewise, some physical properties, some macroscopic properties will depend on the size of the system. Some macroscopic properties will depend on the size of the system. Such macroscopic properties which depend on the size of the system, like volume, like mass, like number of moles, those are called extensive properties. Extensive properties are the properties which depend on the size of the system. Here, this size is larger than this one. So, the volume occurs in here is much more greater than this system. So, volume is an extensive property. Likewise, the properties which depend on the size of the system are called extensive properties. Write down under extensive properties. The properties that depend on the amount or size of the system. Again, the properties that depend on the amount or size of the system. Those are extensive properties. Examples, you can write mass, volume, number of moles, enthalpy. Write down enthalpy. It's a new word. Anyway, write down under extensive property. You will learn it later. Enthalpy. Okay. Then you can understand what should be intensive properties. It's opposite of extensive property, which means it's the properties which independent of the size of the system. If I put some water here as well as here, the density of water remain constant for this system as well as this system. The temperature, if I measure the temperature by using thermometer in this system, is equal to this system if the systems are in room temperature. The pressure above the system, not in the below, it's above the system, is equal to the pressure above the system in here. Anywhere here. Likewise, the properties, macroscopic properties, independent of the size of the system, are called intensive properties. Write down the properties that are independent. The properties that are independent of the amount or size of the system. The properties that are independent of the amount or size of the system. Example, write down example. Refractive index, temperature, surface tension, concentration, likewise. Okay, then just highlight intensive properties with independent of the size of the system. Intensive properties independent of the amount of size of the system. And the extensive properties depend on the size of the system. That two words highlight. That's all you need to know about extensive and intensive property. And another important thing. Look at the board with the just. Extensive properties, mass, number of moles, volume, right? Okay, then if I divide one extensive property by another extensive property, like mass over volume. What's that physical parameter? It's density. Okay, mass over volume is this. Likewise, mass over number of moles. It's more mass. Those physical parameters also intensive properties. So that one extensive property is divided by another extensive property, I can take an extensive property. I can take an intensive property. If one extensive property is divided by another extensive property, so that I can take intensive property. Okay, write down in between these two space. Write down in between these two space. With a pen, use red pen. If any extensive property, if any extensive property is expressed, if any extensive property is expressed per moles, per grams, per cubic centimeter, which means, okay, just write down, per mole, per grams, or per cubic centimeters. It becomes an intensive property. 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 Okay. That's only for the properties of system, about systems, microscopic properties and microscopic properties. Okay, write down under intensive properties: temperature, pressure, concentration, also temperature, basically pressure. Pressure is an intensive property. It's very important intensive property, which described later. Now onwards, pressure is a very good intensive property for us to describe a system, right? So far, any doubts? Indu Varni? Any doubts? No. Others? Can you just give some comment? Any doubts? If you have any doubts, please ask. Don't feel that අයියෝ මම නිකන් මෝඩෙක් වගේ වෙයි දන්නේ කියලා හිතන්න එපා. If you have any question, just ask. Okay. Rebecca, are you clear? Rebecca? I think your sister is Deborah, right? You are here. Rebecca, are you clear? Yes. Okay. Then another part, very important part, state of a system. Okay. New term. Once you get the tube, it's easy. You will have, you can have that note with you, but there are spaces to write until you get it. So just write down in your book. It's okay. State of a system. First write down what is the state of a system and then I will explain what is this thing. Okay. A system, write down. A system is said to be, a system is said to be in a particular physical state. A system is said to be in a particular physical state when specific values of the macroscopic properties of the system, when specific values of the macroscopic properties of the system are known. Okay, what's into that here? Let's take a system like this. It's a closed system. Here temperature is 120 Celsius. Pressure is 1 atm. And volume is 1 cubic decimeter. That are the one. The system is said to be the particular physical state when specific values of macroscopic properties of the systems are known. Then here the macroscopic properties of the systems are known. Here then if I put some water here, can you tell me water is in which physical phase? Gas phase, liquid phase or solid phase? Under the 120 Celsius. It's in under 120 Celsius and 1 atm pressure of 1 cubic decimeter of water is in which phase? Gas phase. Okay. That's the state of a system. Again, now read your note carefully. A system is said to be in a particular physical state when the specific values of the macroscopic properties of the systems are known. Okay, then if I give that system with temperature 70 Celsius, pressure 1 atm, and volume 1 cubic decimeter, now can you tell me water in which is at 70 Celsius? It's in liquid phase. That's why. That's the way. If I know the physical parameters of the system or physical variables of the system, which means those values, then I can interpret in which physical state that particular matter inside the system is, that's called state of a system. Clear? Clear? No. Do you need again explain again? Do you need another clear explanation? Simpler than that? Simpler than that? No. Okay. Are you clear? Okay. Then write down state of a system. Write down state of a system. State of a system is specific, measurable, macroscopic properties of the system. Specific, measurable, macroscopic properties of the system. Those are also, I can tell that state of a system. No, it's beyond that. I will explain that later. Just understand what is the state of a system. If I know the physical variables of physical measurable parameters of the system, so I can explain in which physical state that particular matter inside the system is. Whether it is gas phase or liquid phase or solid phase, like this. Right? We are dealing with physical chemistry, so we need to know exactly what is the physical state of that particular matter. Clear? We are dealing with physical chemistry, so we need to know what is the exact physical state of that particular matter inside the system. Okay. Then write down state variables, a new word. State variables or state functions. State variables or state functions. First write down, then I will explain what is state variables is or are. Write down the variables like pressure, volume, temperature. The variables like pressure, volume, temperature, and composition. That are used to describe the system. That are used to describe the state of a system. That are used to describe the state of a system are called state variables. Variables like pressure, volume, temperature, and composition that are used to describe the state of a system. That are used to describe the state of a system are called state variables or state functions. State variables or state functions. Okay, I think now you got that point. What are the state variables? Are those ones. If I use to describe this system, here the system, I need to describe this system. So I take 1 atm pressure. Here it's about 28 27 Celsius or something. Here in the surrounding, it's 1 atm pressure, 27 Celsius. It's 100 cubic milliliters. sorry, 100 milliliters volume closed system. Okay. I describe this system by using pressure, volume, and temperature. Those physical parameters, those macroscopic properties, which I use to explain the system, which I use to describe the system, are called state variables or state functions. Clear? The pressure, temperature, volume, composition of the system, which are used to describe the system, are called state functions or state variables. Basically, what are the state variables? Are pressure, temperature, volume, and the concentration or composition. Clear that? Any doubts? Any doubts? Are you okay? Are you sleepy? Lamai, are you sleepy? Narendra, are you okay? Okay, small things to know. No, not the small things. We have some things to do. Some. Okay, then another write. Then write down under the as the next point. State functions depend only on the initial state. State functions depend only on the initial state and the final state. State functions depend only on the initial state and the final state of the system, and not on how the changes occur. State functions depend only on the initial state and the final state of the system, and not on how the changes occur. Okay, then another new terms. What are those new terms? Initial state and the final state. So we need to know what is initial state and final state is. Okay. Let's imagine now it's 10. Your mother your hot coffee. Okay. Hot coffee. There is a hot coffee with you now. It's about 250 cubic centimeters or milliliters in volume. Let's imagine 70 Celsius, beyond not more than that. I think 70 Celsius. Once after process happen, it goes to 70 Celsius or 80 Celsius. That the pressure is 180. Okay. Those once the mug is on your table, the starting point with energy exchange with the surrounding. First point, once your mother make the cup of tea, right? It's called initial state of the system. Or else we can say that yeah, this we can take that. It's easy. Initial point. Once your mother bring one cup of coffee to you, that's the initial state of that system. Amma take ගෙනත් දීපු නැත්නම් coffee එක ගෙනත් දීපු පළවෙනි වෙලාව. It's the initial state. Okay, then it exchanges energy in the surrounding. It's exchange energy with the surrounding. It's exchange energy in the form of heat. It exchange energy in the form of heat with the surrounding. So the volume is still remaining, but 250 cubic centimeter, which means you forgot to drink that coffee. Temperature is goes to 30 Celsius and 1 atm pressure. Then once you start to drink that coffee, this is the one, the point. Once the coffee is made or your mother brings you in that coffee. And this is the state where you start to drink that coffee. Okay. This one is called final state of the system. Right? Initial state means initially there is no any heat exchange or energy exchange with the surrounding. The final state after the energy is exchange. Okay. Then write, just draw that. Then I will give some note under the initial state. Leave some space to write. We just draw this copy with these physical parameters. Those are called state variables. Those are called state variables. And this is the initial state of thing. So next week onward, this class is on Saturday from 9 p.m. to 11 p.m. Right? Today is a mixed class. Yesterday I missed the class. That class is there today. Right? Instead of that class, I am doing today class. After all, again the class is on every Saturday from 9 p.m. to 11 p.m. Right? I think this is clear, or I can just the class is anyway. Are you okay with Fridays, Saturday, right? Are you finished? Then write down under initial state the starting state. The starting state of the system. The starting state of the system. Any before any kind of interaction. Any kind of interaction with its surrounding. Before any kind of interaction with its surrounding. Again, the starting state of the system before any kind of interaction with its surrounding. Write down under final state. State after the interaction of system. State after the interaction of system. State after the interaction of system with its surrounding. With its surrounding. You need to know the terms, right? What is initial state of the system? What is final state of state variables? Those you should familiar with them, right? Right? After this lesson, you need to know some idea about what is initial state, what is final state, what are the state variables, what is the system and all. You need to have some idea after these 2 hours later. Sorry, after these 2 hours. Okay. Write down. Write down. If the values of if the values of state functions of a system, if the values of state function of a system are known, if the values of state function are known, all other properties like mass, density of the system become specified. Puta, can I ask a question? Is there any lagging phase in your cameras? Is there any network errors or something? Namai, is there any network errors or something? Can you feel that? Or else are you clear with the lesson with good network connection? Please respond me. One of the students at least. Okay. Okay, then it's fine. Then I feel some network thing here. It's okay. Again, the values of state functions of the system are known. All other properties like mass, viscosity, density of the system become specified. What does that mean? What is that? Okay. For that, we need not the water, we need some honey or something, not the water. For that, by using water, I can't explain that. Okay. Let's take some honey. Yeah. Honey. It 6 Celsius, 180 atm pressure. And yeah, I don't need the volume. It has some specific viscosity. I think you know what is viscosity is. Right? Okay. Once it is the temperature of 30, up to 70 Celsius or something in 180 atm, the viscosity will decrease. Here this viscosity have its value. Viscosity, which contains, let's see, X. In once the temperature increases up to 70 Celsius, the viscosity will decreases. It is less y is less than, right? And we know this particular value if I know the temperature and pressure. That's why they says, if we know the particular state variables, then we can predict other viscosities, density-like factors directly. Normally, density, viscosity, surface tension, and other variables we measure are equal particular, right? We say pH, concentration at 25 Celsius of water. It's a concentration of water at 25 Celsius is 1 into 10 to the power minus 7. Why it's mean that way? Once the temperature increases, that pH value might be different. So that variable is described according to the state variables. Clear? We need to know the temperature pressure to give that intensive variable like boiling point, like viscosity, like density. Clear? Puta, are you clear? Yes. Okay. Then write down new one. Standard state. Give me some second. Wait. Havi. 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 Take the class. Okay. Okay. Then write down standard state. Standard state. Okay. What's mean by standard state? Now in this system, let's see another water system. Let's take another water system. Which means a water bottle. The water system is very closely water bottle. A water bottle. Close water bottle. Standard state means if I use these physical variables like state functions, pressure, temperature, and volume with the standard values. Normally, scientists use the standard values for the pressure to do some enthalpy reaction or physical changes of the reaction in the under standard pressure condition. Right? Like that. Here, the pressure should be standard values, standard pressure. Standard pressure. Standard pressure. It's called, we indicate as P norm. Normally it's 1 atm for the reactions. Normal reactions goes under standard pressure which is 1 atm. Right, the temperature. Normally we don't use standard temperature value for the system, but normally we use 25 Celsius. It's not the standard value, but it's specific values. 25 Celsius or 298 Kelvin. Same thing. For the concentration, if we need some solution, use standard solution as 1 moles per cubic decimeter solution. Right? Okay. Now write down. Let you understand what is that. Standard pressure. Okay, just write down this one. Right. Write down. Standard pressure 1 atm within bracket 1 into 10 to the power 5 Pascal. 1 into 10 to the power 5 Pascal. Write down. There is no defined standard temperature. There is no defined standard temperature. There is no defined standard temperature. within bracket 298 Kelvin is used as specified. 298 Kelvin is used as specified. Third point, when solutions are involved, concentration is 1 moles per cubic decimeter. When solutions are involved, concentration is 1 moles per cubic decimeter. Okay, then chemical reactions I can categorize or that so far the state variables, standard state of the system. Standard state means this pressure, temperature, and concentration of the system which we use to describe a system in this standard values. And is the initial state of the system, final state of the system. Any doubts so far? Now we are moving to last session. That's why I am asking. Any questions so far? Okay, clear. You are clear. Others? Rebecca? Any doubts? No. Clear. Okay. Then write down chemical reactions. Chemical reactions. Today is the basic terms, right? Next week, we will go with the enthalpy lesson, enthalpy session. Today part is also important to go with the lesson. Chemical reactions. I can categorize the chemical reactions into four major parts. First one, spontaneous reaction and non-spontaneous reaction. First one, spontaneous reaction. Second one, non-spontaneous reactions. Write down with me. And reversible process. And irreversible process. Okay. First write down what is spontaneous process. Spontaneous processes are the chemical reactions that occur naturally. What are the natural chemical reactions that we know? Photosynthesis, blooming a flower, seed germination, cellular respiration. Those are natural process, natural reactions, right? Food ripening. Those are chemical reactions which occurs naturally. Likewise, the natural chemical reactions are called spontaneous reactions. We don't need to give more energies to do that. We don't give force to do that. So those reactions are called spontaneous reactions. Clear? Clear? Any chemical reactions that occur in naturally, Those are natural reactions or spontaneous reactions. Okay, write down under spontaneous reactions. These reactions occur. These reaction occurred. These reaction occurred on their own accord. These reaction occurred on their own accord. Write down as another point. Transformation of the system. Transformation of the system. Transformation of the system from initial to final state. Transformation of the system from initial to final state is favorable in a particular direction only. Is favorable in a particular direction only. Write down with black pen or another color. Many of them are natural and irreversible process. 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 Okay. Write down some examples. Seed germination. Blooming a flower. Photosynthesis. Cellular respiration. Those involve more chemical reactions inside that seeds and flowers and plant with spontaneous reactions. Right? Those are all spontaneous reactions. Examples for spontaneous reactions. Those energetic lesson is so beautiful lesson to that. We normally consider only the reactants and products. But there are something here along with that reactants and products. Right? Once the chemical reactions occur from reactants to product, apart from that reactants to products, there is some energy or to reaction to occur, they absorb some energy. So there is some energy transformation here. Energetics lesson is so interesting lesson. While after you learn that lesson, you can understand how when things happen, how the energy release, or two things happen, how we absorb energy, right? Okay. Then what is non-spontaneous reactions then? The non-spontaneous reaction is opposite to its spontaneous reactions. The reactions was not occurred in their own accord. Let's say here in my body, I am a organism, living organisms which contains carbon, hydrogen, oxygen and nitrogen. Basically a lot of carbon inside my body. But there are a lot of oxygen in the atmosphere, 21% in total amount. But by reacting carbon in my body with oxygen, we can't form carbon dioxide. If so, I am burning here. But that reaction doesn't occur. Right? Likewise, some reactions are there which cannot occur in naturally. Those reactions are called non-spontaneous reactions. So once you are given some reaction, you can give me some reaction. You may ask, Miss, this reaction is spontaneous or non-spontaneous? So sometimes I can tell whether that reaction is spontaneous by looking at the reactants and products, but sometimes I can't predict the reaction is whether it's spontaneous or not. So I need to calculations under energetic lesson called Gibbs energy. So to find the reaction is spontaneous or non-spontaneous, we need to know Gibbs value. Before that, we need to know what is non-spontaneous reaction is. Non-spontaneous reaction is the one which does not occur naturally. Okay, write down non-spontaneous reaction. These reactions not occurred on their own accord. On their own accord. These reactions not occurred on their own accord. Then last two, reversible process and the irreversible process. Okay, what is reversible process? This one. A plus B can form C plus D as well as the C plus D convert A plus B back. Those are reactants. Those are products. If the products can retrace to the reactants again, those reactions are called reversible reactions. Normally in chemistry, there are a lot of reactions which are reversible as well as irreversible. Okay, let's first move with the reversible reactions. Just write down this and write down this explanation for reversible reaction. The series of changes carried out on the system during its transformation from initial to final state may be possibly reversed in an exact manner. Then what are the irreversible reactions? So, irreversible reactions are the reactions which cannot convert products into reactants back. Right? Like growth. We can't go our childhood back now. Likewise. We can't change the products into reactants again. Okay. Just one way reactions. The reactions occur in unidirection. A plus B to C plus D. This way. Right now. An irreversible process is one which cannot be retraced. An irreversible process is one which cannot be retraced to the initial state without making a permanent change without making a permanent change in the surrounding. In the surrounding. Okay. Again, an irreversible process is one which cannot be replaced to the initial state without making a permanent change in the surroundings. Okay. For today, that's all. I can't start enthalpy session today. So if I start enthalpy, take again 1 hour time. Normally in physical class, it is 3 hour session. For you, it's 2 hour. I know it's very hard to be focusing online. So that's why I cut the session into 2 hours. Then you are in the 2 hour sessions. I think all clear so far. The basic terms in energetics lesson. Next week onwards, we are going to with enthalpy and enthalpy calculation. So please bring your past paper book with you. It's more helpful to do some questions with me. Next week, I will do some questions in past paper book as well. Okay, so any doubts so far? Are you clear? Or any comment? You need to know something in regarding the lessons or class or anything. This is the time for you. You can switch on your mics and you can talk. What is the past paper book? Wait. Students, this is my past paper book. This is my past paper book. Or else you can buy a past paper book in market. I think it's from 2014 or something. It's okay. Once in my after you joins my permanent groups, I will give the Google Drive with the past paper question from 2000 to 2023. Right? Then you can download those papers while you are doing my session. You can open that PDF and do it. The questions. Then, if you are continue the class with me, you have some instructions. Please drop me a message in WhatsApp. So, you will some instructions how to join with next session onwards. Okay, that's all. Any doubts? Anything you need to know? The permanent class time is not that. It's in Saturday, 9 to 11 p.m. Right? Anything you need to know? Once you miss the class, you can have recordings. Anything, any doubts? Are you clear? Any comment regarding the class? No. No? Are you there with me? Rebecca? Understand the lesson very well, miss. Thank you. Okay. Then I will stop the lesson. So good night, students. Let's meet in next session. Thank you. Good night.